Hello, this is Edison, and I'll be reviewing the Tic Tac Toe project we covered in class. Keep in mind that the way I write out the program isn't necessarily the way you need to write it out, but I feel like this is the best way to explain the core concepts behind it, and thus I hope that you'll learn more out of this rather than just copying it word for word. But who knows? First off, I wanted to divide the program into four parts, right? Because that way it would be easier to read, easier to organize. So, for one, I had a function to print out the board. Return is just a placeholder over here. You don't have to worry about that for now. This is just so it's syntactically correct as of this moment. And obviously, print board will draw out the grid, the tic tac toe grid that we want. We're going to have another function called update board, right? And update board will obviously update the board based off of which players, based off of which position the player wants to put their mark in and which mark the player is. So whether they're an X and an O, and what position they want to put that X and O in. Next, we have a check winner function. And this will obviously check whether there's a 3 in a row, 3 in a column, or 3 in a diagonal, and return whether it's a win or not. If there isn't, it's going to return false. And lastly, we have the tic-tac-toe game itself. This is where the game will be run, and this is where the game loop will be. So let's start off with the game loop, because that's the most broad aspect of the program. First off, we obviously need to have some sort of board to play the game on. So that's why we're going to initialize this 2D list board to represent it. Okay, I just copy and pasted it, where each of these numbers is each of the elements is going to represent the position. After that, we'll have a turn variable, right? This turn variable doesn't refer to the number of turns that has taken place, but rather which player is playing. I know it's sort of confusing, but you will have to deal with it for now. This refers to whether it's an X or no. And lastly, there's going to be a count variable. This is going to refer to the turn number. And we'll start it off as 0. It should start off at 1, but this is how I wrote it out. And now we're going to start off with the loop, right? We want it to last up to 9 maximum turns, so while count is less than 9. If you set count equal to 1, then you could technically say less than or equal to. But for now, since I set it to 0, we're just going to have less than. So while count is less than 9, right? Where do we start off first when we want to start off with turn number 1? Well, first, I think it's important that we print the board out, okay? So we're going to call upon the print board function. But how are we going to call on the print board function? What is this referencing? Where are we drawing this board from? We're obviously drawing it from this board over here. So that's why we're gonna have a parameter called board. This doesn't necessarily refer to this board, but in this case it will. They just happen to be the same name. So since we have a parameter here, we're gonna need a parameter over here. What does it mean when we print out the board, right? We're trying to draw it out. So I feel like this is the best way of drawing it out. We're going to have for row in range 3, we're going to print board row. So that way it prints out the 3 rows, and each row will have 3 columns. So basically each row will be just a list from 1, 2, 3, 4, 5, 6, and 7, 8, 9. I feel like that's just going to be the simplest way of drawing it out. You don't have to worry about it for now. about how nice it looks or whatever. After we print out the board, we want to figure out which player is playing and which uh, and where they want to put it. So first, we want to ask the user. We're gonna have this position, right, where they want to put it, and we're gonna set it equal to. We're gonna have it take the user input and say, let's just say, player so and so. In this case, it's gonna be player 1, since that's the turn number initially. Enter a position. That's what we want the users to do. And we need to make sure that since position is an integer, we need to make sure to cast this as an int. Just like how we had to cast the turn, which was initially an int, into a string in order for it to compile correctly. So now we have whatever the user wanted to, whatever position the user wanted to put it in. In this case, player 1. After that, we'll update the board, obviously, with what they did. Update board, we're obviously going to have to reference the board we're trying to update. The turn, which player it is, whether it's player 1 or player 2, X's or O's, and the position that they updated it with, okay? So how do we write the update board function, right? Since we have these parameters, we also need to have them over here. Whoops, extra parentheses. And we don't need that return statement anymore. Well, first I created a dictionary, right? Let's just call it D for now. And this is a good way of having 1, the turn number, well, not the turn number, the player represent the actual mark they make. So 1 corresponds to X, and we're going to have 2 correspond to O. Okay? Keep in mind that these are both strings, so you need quotation marks around them. And then, now, how are we going to know which position to update, right? We're going to navigate through the list, right? We're going to iterate through every single element. So we're going to have for row in range 3. This range just refers to how many rows there are in total. Since we know that a tic-tac-toe board is 3 by 3, we can just hard code it as 3. For col in range 3, this refers to the columns, obviously. And we check, is the value of the element indexed at row column is equal to the position that the player wants to put their mark in. If they're equal, only if they're equal, then you set it equal to their mark, or in this case, the dictionary value of the key turn. So for instance, let's just say player X is playing, right? I mean player 1 is playing, and they want to put on a 5, right? You iterate through, and once that element value is equal to 5, is equal to the position, then you set that equal to, you know that you're referring to player 1, and player 1, the value, it's indexed at 1, so the value is X. So then over here, you set the element over there at position 5 equal to X. Okay, so now that we have the board updated, we're able to update the board, but we need to find the way for the game to end, or for a winner to be chosen. So let's see. We're going to check if there's a winner. Actually, we shouldn't check that yet. I think it's more important that we check we make sure that the turns alternate first because that's a key concept. That's a key rule in tic tac toe. You need to have the turns go from X's to O's, O's to X's. So we first update the turn number, right? Count plus equals 1. That just is the same as count equals count plus 1, in case if you guys are wondering. Anyhow, now that we updated it, if the player was initially X, right? You set the player now it's gonna be player 2's turn or player O's turn. Else if turn is equal to 2, we're gonna set it equal to 1. This basically allows the turns to alternate between each other. So over here, in between changing turns and changing the turn number and changing which player is playing, we're going to have a check winner function, right? Because that's how we want the game to end. If there's check winner, and we're referencing the board because we need to figure out who's winning based off of the positions on the board, the marks on the board, and who the player is, because obviously when you think about it logically, whoever played the last move, if someone wins, whoever played the last move has to be the winner because they were the last one to put it down, and that's obviously that they had to put down whatever position to have it 3 in a row. So if that's true, then you print the board again, and you print that the player plus whatever player won. Okay, this is how you write that out. And then you return. When you return over here, that basically means that you exit the loop. Otherwise, if it does reach 9, right, and it does exit the loop, now this is being typed outside of the loop, right? You want to print out the board. Again, we have the print board function we're calling once again, and we'll print it's a tie, okay? Because once there's 9 turns, and if this is never called, if this never exits, that means that this will happen. So I had this check winner function, right? How are we going to write this out? Well, first, as I mentioned before, you need the board to figure out the positions of each mark, and you need to have the turn of whichever player was playing last. So whether it's X or O. So let's write that down here as well. So how did I check for a winner? Well, to do this, let me paste everything out and I'll explain it step by step. So there is a you see over here, right? There's a set, as you can see by the curly braces, of tuples. And each of these tuples, right? There's going to be tuple 1. Well, it's sort of like a nested tuple, a 2D tuple if you really think about it. There's going to be this, okay? This represents a winning pattern, right? And these are the positions. So, for instance, on the board 0, 0, 0, 1, and 0, 2, that refers to this one, and this one. And if all of these are the same, then we could say that that player won based off of whichever mark it was. And then same for this one, same for that one. This is This isn't something that you guys have to memorize. This is just kind of hard coded in. So you guys can copy this down if you really need it. And then we check um, for x1, x2, y1, y2, z1, z2 in winning positions, right? We check all of these winning positions in here. And we know that we have this piece, right? Piece is just basically the mark is equal to whatever it is at that spot. If y1, y2 equals piece and board z1, z2 equals piece. This basically means if 0, 0 is equal to whatever turn it is, and 0, 1 is equal to it's equal to 0, 1 and 0, 2, then you return true. Yes, it's a winning combination. So for instance, let's just say piece is equal to the player 1. So let's just say if it's an x. So if 0, 0, the element at 0, 0, at 0, 1, and at 0, 2 are all equal to x, then you return true. Yes, there's 3 in a row. In this case, it's 3 in a row. And that there is a winner. Otherwise, you return false. So if you return true over here, this block of code is called, and that's why there's a winner. And if you return false here, then this is never called, and it just goes all the way until this loop finishes, and then once the loop is over, it calls this block of code. So now that we have all our functions written out, the game should work. We just need to call the Tic Tac Toe function, the actual game function, and it should run smoothly. So player 1, let's just say player 1 wants to go in the middle. Whoops, I think I forgot to a line of code. Let me just put that in. I think I need to put count over here. Okay, let's run that once more. Oh, that's why. It's because I accidentally used a I used a comparison operator over here when it's supposed to actually be setting it equal to 2 and equal to 1. These are called logical operators. I mean, these are called comparison operators to compare if turn is equal to 2. They're using if statements. And this is just setting it equal to. So let's run that again. My bad. So now it's going to go to player 2. And let's just say player 2 picks position 8, right? And then let's just say player 1 picks position 4. Player 2 picks position 7. And then player 1 picks position 6. Then player 1 has 1 because there's 3 in a row over here. If you guys have any questions, feel free to comment under the announcement I make. Thank you.